Hello, this is Mr. Win, and this video is about inverse trig functions. We'll go over arcsine, arccosine, and arctangent. So remember that for a function to have an inverse, it must pass the horizontal line test. That is another word for 1 to 1. That means each x is exactly 1y and each y is exactly 1x. So if you look at y equals sine x, it horribly fails the horizontal line test. If I use this horizontal line, it's touching this line multiple times. 1, 2, 3, 4 right there. 2 times right here. Up here, it's at least 1, 2, 3, 4. And it keeps going. Remember, this is periodic, so it touches infinite number of times. So it fails. It does not have an inverse. But if you restrict its domain from the interval negative pi over 2 to pi over 2, here's our graph. This passed the horizontal line test. All right, it doesn't touch multiple times. So there are three properties that hold true. Sine of x is purely increasing. It uses the entire range of values for sine of x from -1 to +1, just like the unit circle. And sine of x is 1 to 1. It passes horizontal line test. All right, each x is exactly 1y, and vice versa, each y is exactly 1x. All right, on this restricted domain, sine x has a unique inverse function called the inverse sine function. This can be written either as y equals arc sine of x, or you can say y equals sine inverse of x. Same thing. Also remember that an inverse switches all x's and y's. That means the original domain and range are switched too. Now note the domain is restricted here. So for trig, we usually have the angles as the x. Again, it could be in degrees or radians. And the trig values as the y. For inverse graph, the trig values are now the x and the angles are now the y. So look here, we're used to radians as the x-axis and the value between -1 and 1 for the range. But now, the -1 to +1 is our new domain. And the angles in radians is now our y-axis. All right, you will need to use knowledge of the unit circle in reverse and make sure we're within our restricted domain. We'll try some problems on the next slide. So without a calculator, find each of these. Arc sine of -1/2. So you're supposed to ask yourself, at what angle, and again we're in radians, is sine of x equal to -1/2? So you think about unit circle, where's sine negative? It's on the bottom quadrant, so quadrant 3 and 4. And for -1/2, those are the radian values 7 pi over 6 and 11 pi over 6. Now wait a second, 7 pi over 6, 11 pi over 6 is not in our domain. Our domain is supposed to be negative pi over 2 to positive pi over 2, or this is the range. Domain of the original or range of the inverse. So what we need to do is find a coterminal angle. So all we do is add or subtract 2 pi until we find that's one that's in the first quadrant or fourth quadrant. So 11 pi over 6 minus 2 pi gives us negative pi over 6. That is the answer. Let's try sine inverse. That's the same thing as arc sine of root 3 over 2. This is a positive value, so that's in quadrants 1 and 2. If you think of the radians, you should get pi over 3 and 2 pi over 3. But which one is in our restricted domain of sine, negative pi over 2 to pi over 2? Or you can say the range of arc sine. That's just pi over 3. 2 pi over 3 is bigger than pi over 2, so that's out. Last one, sine inverse of 2. So what angle in radians has sine of that angle equal to 2? Well, sine of any angle, between 0 and 2 pi or 0 and 360 degrees does not go below -1 or above +1. Right, so this is outside of our range. So because it's outside the range of the original sine function, it is outside the domain of the inverse sine function, so it's undefined. There is none. Remember, if you see sine inverse or arc sine, that means this is talking about an angle. Remember, this number in the parentheses, that's supposed to be the value. So the same idea of restricting the domain for cosine and tangent will allow us to see a one-to-one function and define the inverse cosine and inverse tangent functions. Here are the graphs and characteristics of the main three. So we just talked about arc sine or inverse sine. Here's arc cosine or inverse cosine. And here's inverse tangent or arc tangent. All right, notice the domain of inverse sine and inverse cosine are the same, -1 to +1 closed. Of the range, negative pi over 2 to pi over 2 closed for inverse sine. For inverse cosine, 0 to pi. And then for inverse tangent, domain's all numbers. It goes forever. Remember, it's the vertical asymptote, or I guess now it's horizontal asymptote, because this is a reflection of the diagonal y equals x. But the range goes from negative pi over 2 to positive pi over 2. Open. All right. It is very good to know the summary inverse functions. It pretty much says what it has right here. But I'd say you should learn or remember which quadrant each inverse function is defined in. So arcsine and arctangent are in quadrant 1, quadrant 4, because you know negative pi over 2 is backwards 90 degrees, and then positive is forward 90 degrees. So tangent and sine's inverse was the same thing. Then cosine, where is it from 0 to pi? Well, that's the first and second quadrant, if you think of the original. Alright, so next we'll do compositions of functions. Remember, inverses do cancel each other out and return the original input, provided we stay in the domain for each. So remember, for all x in the domains of f and f inverse, inverses will have the following properties. F of f inverse of x will be x, and then reverse as well. F inverse of f of x will give us x. So here are the properties. So if we're trying to do the arcs sine, arc cosine, arc tangent, make sure between -1 and 1 or all row numbers, because that's how the graph of arc cosine, arc sine works, or arc tangent works. Again, going back here, arc tangent is all row numbers, right? It goes left, right forever. For arc sine, arc cosine, you're going from -1 to +1 for the domain. Alright, but I'll give you back the original. Now if you're going the reverse, if you're going sine of y, cosine of y, tangent of y, we know we can put in almost any angle, but then you have to be careful. Are those in the domain of arc sine, arc cosine, arc tangent? That's why that would be between negative pi over 2 and positive pi over 2. For sine and tangent, because they're quadrant 1 and 4. And for cosine, arc cosine, you do between 0 and pi. Alright, also make sure you know the inverse properties do not apply for arbitrary values x and y. Again, it has to be within the domain. So for example, let's try an arc sine of sine of 3 pi over 2. Well, sine of 3 pi over 2, you know that is on the bottom, that is -1. So we can say this is now arc sine of -1. We replace sine 3 pi over 2 with -1. Now where's arc sine -1? Well, arc sine is restricted, so that goes to negative pi over 2. Remember, arc sine is going from negative pi over 2 to positive pi over 2. So they're saying where's sine -1? Well, that's negative pi over 2. But that's not the same as the original problem. Alright, so we'll have issue. It's the property arc sine of sine of y equals y is not valid for values outside of this interval. Alright, without the calculator, find each of the following. Tangent of arctangent of -5. So ask yourself, is -5 in the domain of arctangent? Arctangent went sideways forever, so yes, it's in the domain. If it's in the domain, then we can just say, oh, -5 comes back out. It's okay. Here, find arc sine of 5 pi over 3. Well, 5 over 3 is not in the range of arc sine, so we need to find a coterminal angle in quadrant 1 or quadrant 4. If you do 5 pi over 3 minus 2 pi, you get -pi over 3. Alright, we then compute arc sine of -pi over 3 gives us -pi over 3. Here, cosine of arc cosine or cosine of inverse cosine of pi, well, is pi in the domain of arc cosine? And the answer to that is no. Remember, it only goes from -1 to 1. Right, we can't find where is cosine of an angle pi. Where's 3.14? When cosine's range is from -1 to +1. So yeah, that's why it's outside of arc cosine's domain. Alright, so it's outside of the domain, it's not defined. Last two slides, we do compositions of non-unit circle angles. So here, find the exact value of tangent of arc cosine of 2/3. So first, let's ask yourself, what does arc cosine of 2/3 even mean? Remember, when you see the arc sine, arc cosine, arc tangent, or the inverse, they're talking about angles. They're saying, what angle gives you this cosine value of 2/3? Alright, so let's just call it theta. Theta equals the angle arc cosine 2/3 and draw the triangle. Now, we do need to know that arc cosine is only defined in quadrants 1 and quadrant 2 from 0 to pi. So since they give us positive cosine, we must be in quadrant 1. We cannot be in quadrant 2, 3, or 4. So I'm going to draw a right triangle. Here's theta. Cosine ka, adjacent over hypotenuse, is 2 over 3. To find this missing side, you do Pythagorean theorem. So when you do the math, you get square root 5. Now that we have our finished triangle, we can find any of the 6 things. Sine, cosine, tangent, secant, cosecant, cotangent, right? Tangent is TOA. So tangent of theta is O over A, so root 5 over 2. No need to fix that because there's no square root on the bottom, so that is the answer. Let's try one more. Find the exact value of cosine of arc sine of -3 over 5. So again, what does arc sine of -3 over 5 mean? Again, this is the angle where the sine gives you the value of is negative 3 over 5. Alright, so find the angle where the value of sine, Alright, so I fixed that typo. It's saying find the angle where the value of sine is negative 3 over 5. So we'll call it theta again, or whatever you want, and draw the triangle. Now sine is negative, so we have to be in either quadrant 3 or 4, but arc sine is only defined in Q1 and Q4. So we have to be in quadrant 4. We cannot be in quadrant 3. So we have an upside down triangle in quadrant 4. They said sine opposite over hypotenuse is negative 3 over 5. Remember, when it's going down, you want negative. When you're going left, you want negative. Hypotenuse is always positive when you do these. Alright, we do Pythagorean theorem. Find the last side. It's 4. Now they want cosine, so it's going to be ca a over h, so it's going to be 4 over 5. If they wanted secant, secant's related cosine is reversed, it'll be 5 over 4. If they wanted cosecant, that's opposite sine, it'll be negative 5 over 3. If they wanted tangent, O over A, it'd be negative 3 over 4. If they wanted cotangent, it'd be A over O, 4 over negative 3. Alright, so you should be able to find any of the 6 trig functions. All we are doing is drawing our triangle and finding out the sides by Pythagorean theorem, because right now we're not in the unit circle. There's not a special 30, 60, 90, or 45, 45, 90 triangle, and it's not a special angle that you should know. Alright, that's it for the video. Hope you enjoyed it. Make sure you ask any questions. Thanks. See you soon. Bye.